So listen, we're starting section 3.10 today, 3 days of this, 2 days next week of 3.11, 2 days of test review, and our next test is March 7th, next Friday, okay? Just like section 3.9 that we did the last 2 days, this stuff is all about knowing the unit circle, okay? So if you still, guys, if you're still struggling with, and I'll point it out, those moments, if you are still struggling, you're at a disadvantage at this point. You have to know your trig, okay? And I'll explain what I'm talking about in a second. So we're solving trig equations for the next few days. And here is a trig equation right here, sine x equals 1/2. An equation just means it has an equal sign in it. And what we have here is a representation of this equation on this interval of the x-axis. So what this is a graphing calculator, like screenshot if you would, where we have the sine x is one side of the equation, 1/2 is the other, there's the 1/2, there's the sine, and then the intersection function was used to find where the solution is. So intersection on your calculator is an awesome way to solve any equation. You just put one side in and the other side in and use intersection, that'll give you the solution. And it says there are 5 solutions here. So let's just talk about that. If I wanted to spend a bunch of time and like break down the x-axis here with you, we could, but just trust me, what these thetas are negative 7 pi over 6, pi over 6, 5 pi over 6, 13 pi over 6, and 17 pi over 6. So from negative 3 pi over 2 to 7 pi over 2, we have 5 different solutions where sine is 1/2. Now you can probably imagine that since sine has a domain of negative infinity to infinity, these just keep continuing. That's just 5 that we see, but it continues on and on and on and on. So we have to have a more realistic way of solving trig equations besides sitting here for the rest of our lives and just adding them all to our list, okay? So here's what we do. We focus on the unit circle. We learned the unit circle. What you would do is this. You'd say, where on the unit circle is sine 1/2? By the denominator. And I'm sure you guys can see that it's the denominators of 6, right? All of my denominators of 6 are square root of 3 over 2, 1/2. And sine is the y value. So I know my values of x are going to be denominators of 6. So let's just answer this question based on what we know the unit circle. Forget the whole x-axis. So what you would say here is that we know that sine is positive 1/2 at denominators of 6, okay? Remember that on the unit circle, there's 4 denominators of 6, right? 1, 2, 3, 4. All of them have a sine value of either positive 1/2 or negative 1/2. We have 2 positives, we have 2 negatives. So what we use is our all students take calculus. And whether you write it or not is your business. I write it for every single problem. It's very helpful to me to know where sine is positive. Sine is positive in quadrants 1 and 2, right? Remember how to use this. This is where everybody's positive. And then you can just name these. Quadrant 1 would be Quadrant 1 is just pi, and then quadrant 2, we subtract 1, okay? There's what we just saw, okay? But what if it said, give me all the solutions, forever, all of them? Well, obviously, we couldn't keep doing this. We would just take forever. So we write this, sorry, I have to squeeze it in here, plus 2 pi k after them. And let me remind you what 2 pi k is, because you've seen it before. 2 pi is the period of sine, and cosine, by the way. So this angle, sine is going to be 1/2 every 2 pi in both directions. I could add 2 pi, another 2 pi, I could subtract 2 pi to the back. And then same with 5 pi over 6. So the period of sine is 2 pi, and k is any integer. It could be 1, it could be negative 1, it could be 5. 175. We could find any of these that hit along the x-axis, okay? So let's try another one. We are solving equations now with words in them. Because think about like elementary school, early middle school, you did a ton of math with numbers, obviously. Then you had that pre-algebra or algebra teacher that said numbers in your math. And then you had teachers like me now who are putting whole words in your math. And now we have to solve with words in it. So what we want to get is our trig function and its variable by itself. This one was already given to us. Sine is the trig function. You could have cosine or tan. X, theta, any variable can be there, okay? And you want that by itself on one side. And guys, you just use your regular old algebra skills to make that happen. What would I do first here to get my x by itself, my cosine x by itself? Add 1, right? Do you have to show the work? Nope, not for me. If you want to show the work, go right ahead, but I don't require you to, okay? And then this is multiplication, so the opposite would be division. So sometimes you have to do a little work to get the trig function and its variable by itself. Then you use your unit circle knowledge. Now, this is the part I'm talking about. If you have to have this out during homework, if you have to look at my key to get through the homework, you are not going to do well in this next test. That should tell you you have to do some work to learn this trick. Because don't look over there. Think to yourself, where is cosine 1/2? What denominator has a cosine of 1/2? It's all of my denominators of 3. That should come to you in about 10 seconds or less, okay? Scan the unit circle. Where do I see an x value of 1/2? That's at all of my denominators of 3. So I know that there's going to be 2 of them. And that's going to be a denominator of 3, okay? And now we need to figure out the numerators. That's where all students take calculus here. Where is cosine positive? These 2, right? And the 4th, right? Both of them. So quadrant 1, numerators are all pi. And then at quadrant 4, at 5, I go to 7, 11. 5 is the one down at the bottom. And then, of course, 2 pi k covers the general, also means all solutions. Sine and cosine both have a period of 2 pi. So that will repeat every 2 pi in both directions, okay? So we know the unit circle, or hopefully we do, and then we can just say, but we also know it's going to keep happening forever and ever and ever, okay? Let's try some more. Sine x is already by itself, so we don't have to do any rearranging. We go right for our denominator. What denominator has a sine of square root of 2? Don't even worry about this, the SIGN. Just what is the denominator I'm going to use for this? 4, right? All of my denominators of 4 have square root of 2 over 2, square root of 2 over 2. It is negative, so we 3 and 4, right? Well, A means all are positive. S means sine is positive. Sine is positive here and here, so we want quadrant 3 and 4. So x equals quadrant 3. Don't forget how to maneuver through the quadrants. In quadrant 3, I add 1 to my denominator. And then in quadrant 4, at 5, I go to 7. There it is, 11. And I'm just being lazy by writing it once, but you get the idea. So you can see, I'm guessing already, those of you that are able to come up with this quickly, you're not feeling much stress, okay? If you're struggling with this part, that is a sign that you are not prepared right now. You've got to do some studying. I'm not saying it to be mean. I'm saying it because I care. I want you to learn this stuff. But this is stuff, it has to be up here. There's no other way of finding it, okay? There's nothing else you can do except have it up here. All right, let's solve this equation. Again, we're doing math with words. If seeing the words confuses you, you could rewrite this taking out the word cosine and then solve it like that and then put it back in. We're not going to go that far. But if you took out the cosine and you looked at this, I don't think anyone would have a problem solving for x. I don't think. What would be the best first step? There's lots of first steps. What's a good first step? No, not add 7. Turn around. What would I do first? Yeah. Usually, now, listen, guys. It's not wrong to say you want to add 7 first, okay? It's not necessarily wrong, but when you have variables on both sides, this is a pet peeve of mine. I feel like some algebra teachers are not good about teaching algebra. Whenever you have variables on both sides, it typically makes sense to start with the variables, okay? So you could subtract 14 or subtract 18. Turn around, said 14. That way we get a positive. That's what we're going to do. But now I'm going to go down here. So I'm going to subtract 14 cosine x from both sides. Again, I don't need to see the work for this. Of course, show as much work as you want. What would I do next? Add the 7. Then divide by 4. Okay? So what is the denominator that has a 1/2 as its cosine? We already had this problem, actually. Yeah, it's a cosine is positive here. 5 to go with 7, 11. Yep. Okay, great question. Why am I not writing plus or minus 2 pi k? Because k could be a negative number. So that'd be 2 pi times negative 1 could be subtracted. It's a good question. Is it always going to be plus 2 pi? It will be for sine and cosine. And it's a good question, and I'm going to talk about when it's not in a second. So before we get to the homework where I actually have to show you how to do what he's talking about, so good call, let me show you how to do these on the calculator. Super, super easy. You guys have done this a million times already, okay? So it says to use a calculator to solve each equation. We're going to do 3 decimal places instead of 2, just because that's better. And these directions are missing something. It doesn't say find all solutions or general solutions. It should say this, and it does in the homework. It should say solve on this interval. Guys, this is code for the unit circle. When you see these directions, that's when you would leave off the 2 pi k. So up here, if it had said solve for the interval of 0 to 2 pi, you would have just left off the 2 pi k. Here's the 2 answers that are on the unit circle. It's not asking for all of them, okay? The calculator ones will always say this, so you don't have to worry about that. And all we're going to do is put it in our calculator. So clear your RAM. You don't know who messed with your calculator. Like me, I just was playing with mine. And we go up to y equals. Now, guys, doesn't matter which one you call y1, which one you call y2. Just type them in. Everybody should be doing this. Tan x, and remember, x could be theta, it could be any variable. On the calculator, we use x, no big deal. And 5. And once you do that, before you graph it, let's change our window. Because remember, it goes from negative 10 to 10, but all we care about are the solutions between 0 and 2 pi on the interval. Interval is the x-axis. So 0 is my min, x-min, and 2 pi, use your pi symbol, is your max. Now look, because this confused some people earlier. If I arrow out of that, it changed my x max to a decimal, as that is 2 pi. 3.14 times 2 is 6.28, blah, blah, blah. So it's fine. It just does that, okay? So if you put 2 pi in there, it changed it to a decimal. Who cares? Let's look at the graph. You'll see some squiggling happening, and then you'll see that line, which is y equals 5. What function am I going to use to find my solutions? Intersect, right? And there's 2 of them, because there's 2 on the unit circle, right? So second calc, 5. Guys, make your life easy. Some of us are like, oh, I have to find this one first, then this one. It doesn't matter what order your answer is in. Your calculator defaults to putting the cursor right in the middle. That's closer to this one. I'm just going to find this one first instead of spending time moving my cursor around unnecessarily. But if you do you. So I'm just going to hit enter here. And remember, with intersection, it'll jump automatically to the horizontal line. Enter again. Do I want you to guess? Yes, please. And you can see your first answer is 4.515. Make sure we're rounding correctly. So that's this intersection. Let's find the other one. Second Calc 5. And we're just going to use our left and right arrows to maneuver around. So we got to get past this squiggle. There might be a way to jump faster. I don't know. All right, so I just want to get onto this squiggle somewhere. It can be above it. It can be below it. Doesn't matter. Hit enter. It'll jump to the horizontal line. Thank you. Enter. Yes, guess. And you should get 1.373. And because it said just on the unit circle, we don't bother putting anything after that. Okay? Say it again. All right. Let's do this one, and then we'll go to the homework, and I'm going to do 3 with you that I have to do. Cosine x 0.6. I already have my window set up for my last problem, so I'm good. Notice I don't have to close my parentheses if I don't want to. If you do, it's fine as well. And let's see. So there's cosine, right? Up, middle, down, middle, up. There's 0.6. There's 2 points of intersection. Second calc intersect. That's perfectly good starting spot. Enter, enter, enter. It found that first one. You can see where my cursor ended up. That's the first solution. Why is that important? Well, it's not really that important, but just so I know where to go to get my second one. So we've already found this one. Okay? So second intersect, arrow over. Just get somewhere close to it. You don't have to be super close. You can be pretty far away. Here's a great spot. Enter. It always jumps up to the horizontal line. Enter. Guess. And we get 5.356. So the calculator ones is using that intersection feature that we've used so many times in this class. It's a big, big important concept. Plus, it's great. If you're using a graphing calculator on the SAT and you have to solve something, you now know how to solve any equation by using a graphing calculator. It's pretty cool. And I'm going to show you how to do inequalities as well, where you can have shading on the calculator, shade above, below, all that stuff. Okay, so let's go to the homework where I have to do some problems with you, teach you some problems by doing something. I'm going to do 1, 3, and 8 with you, and I really need you to do especially 3 and 8 with me because there were no examples like that in the homework, okay? I mean, in the notes, so I have to do them in the homework. One, 3, and 8 I'm going to do with you. 1, 3, and 8. And then you should have no problem finishing. I'll come around and help you. You've got stuck on any of the calculator stuff. Okay. While I have your attention, number 10 should have parentheses around that x. Okay? So to get the right answer in your calculator, put parentheses around the x. That is a mistake by the lady. Okay? Everybody fix that? Okay. So in number 1, we already have the sign and the variable by itself. Remember, it can be x, theta, any letter here. It doesn't matter. Okay? So we don't have to do that. Now we just look for what denominator. What denominator has the sign as square root of 3 over 2? That's 3. Good. And then sign is negative. Sign is negative. Here. Right? So in quadrant 3, we add 1 to our denominator. And in quadrant 4 at 5, 7, 11. And it did ask for all solutions, so these would both get a 2 pi k. So I just wanted to remind you what the easiest problems are. Okay? Skip to number 3 and number 8 with me because this is important, and there were none like these in our notes. what I want you guys to pay attention to is tan. Anytime there's a tan in a problem, you got to be on your toes. And I'll explain why when we get to that step. Okay? So first thing is to get tan theta by itself. So I'm going to subtract 1. And what denominator has tan values of 1? Yes, this is our denominators of 4, or tans of 1. And all students take calculus. Tan is negative in 2 and 4. Okay? Everybody with me? So my first answer, theta x, doesn't matter, is going to be denominator of 4, quadrant 2, you subtract 1 from your denominator. Here's the first thing you should notice that's different. What's different? Yeah, tan has a period of pi. That was one of the differences between sine and cosine, 2 pi, and tan, pi. So that's important. How about this? We don't need the other answer. The other answer is technically what? 7 pi over 4. But does anybody know why I don't need to write it? Because of pi. What's 1 pi away from 3 pi over 4? If I add pi to that, right? 4 pi over 4. That's 7 pi over 4. Tan is special. Its period is much shorter. So you'll always cover every answer with just one of your answers, okay? Because remember, the unit circle is 2 pi for a full circle. Half is a pi, 1 pi. So if I'm at 3 pi over 4, 1 pi is right here at 7 pi over 4. So technically, you don't need to list the second answer. Would I mark it wrong? I wouldn't mark it wrong because it is technically an answer. It's kind of like, why are they writing that? Because it's already covered here. But I wouldn't mark it wrong. Just be aware that like multiple choice, you'd only see one answer, and I would mark it wrong if you put 2 pi for tan. Okay, so be careful. Tan is 1 pi, right? Number 8 has something really wonky in it. I wish I could get rid of that word in my vocabulary. I feel like such an old lady when I say wonky. Tomorrow we're going to be doing much more complicated equations with trig functions like factoring, like literally chart problems with words in them. But you can kind of foresee that this might have been some kind of factoring, and it's already written in factored form for us. It's okay that there are 2 different trig functions in the same problem. It does cause an issue in a minute because tan is always something that's a little tricky. So what I'm just going to do right now is set each of these equal to 0 separately and solve them separately. Right? As long as there's a 0 over there, I just solve, add 1 to both sides, and then answer it just like I did all the other ones. So I added 1. So we just did this a second ago, right? Where's tan 1? We know that that is our denominator of 4. And the first one where tan is positive is quadrant 1. And we can stop there. Okay? How about sine of 1? Anybody know? Pi over 2. I see a sine or a cosine with a 1 or a negative 1 or a 0. I know it's one of these guys. Good job. So sine is 1 just up at the top, right? That's the only place. So x equals 2. It's going to happen again here, again. But here's I want to see if anybody knows. Nobody's been able to say, and I totally understand if you don't get it. Why is that not part of my solution? Why is that extraneous? I told you there was something really weird in here. Because of what? What's undefined? For what trig function? Tan. Good, Tathan. So here's the thing. This is a family. What works for one has to work for all. Okay, think of it like that. All right? And anytime you have tan hanging out with somebody else, and that somebody else has a answer of pi over 2 or 3 pi over 2, right? Tan is undefined at the top and the bottom because you get a 0 in your denominator. It's considered extraneous because you cannot have a pi over 2 for tan because it's undefined. There's an asymptote there. You know that. So it's not allowed to be in the answer. And we've seen this before. Extraneous just means you did everything right. You did everything your teacher told you were supposed to do, but it doesn't fit in the original equation. And that's one of those situations. So that would be tricky, as you can see. And so we just want to remember, anytime we have tan, we got to be ready for something weird. Okay? Tan's the only one that gives us a problem. It's bulky on Canvas too, but I can fit them all up here. Anything you need help with, guys, please ask. Don't copy. If you are copying this, great, you'll get a perfect homework score. Awesome. Not going to help you on a test. Yeah. 1/2 minus 1, right? You would subtract 1. That'd be negative 1/2. And then that negative in front. A lot of people ask me about that problem. When I subtract 1 from both sides, no, I'm doing it for anyone else that might need it. 1/2 minus 1 is negative 1/2. Remember, this is like a negative 1 in front. It just changes the sign. So that's